Hey there, and welcome. Today, we're going to go on an adventure into something you probably see every single day, but maybe haven't really, seen. We're about to take a guided tour into the incredible, secret life of a leaf.
I mean, seriously, have you ever stopped to think about it? How does a gigantic tree get enough food to grow so big? It's not like it can just order a pizza, right? Well, the answer is hiding in plain sight, in thousands and thousands of its little green leaves.
All right, so here's our game plan, our tour map for today. First, we'll get our official welcome. Then we'll check out the factory blueprints, peek at the different designs and delivery routes, find out what this factory actually makes, and then we'll meet some super cool special ops leaves before we wrap it all up with a quick summary. Sound good? Let's go. Okay, first stop, I want you to forget everything you think you know, because a leaf isn't just some boring, flat, green thing. Oh no. It is a super high-tech, solar-powered food factory. It's the plant's kitchen, its power station, and its lungs, all rolled into one amazing package. Now, every great factory needs a solid blueprint, and a leaf is no different. We're about to break down the three main parts that make this whole amazing operation work. First up, we've got the lamina. Now, that's just a fancy word for the main leaf blade. You know, the big, flat, green part. Its whole job is to be a giant solar panel, soaking up as much sunlight as it possibly can to power up the entire factory. Next, check out the petiole. See that little stalk that connects the leaf to the branch? That's it. And it's more than just a connector. It's kind of like the main hallway of our factory. All the raw materials come in this way, and all the finished products get shipped out through here. And running right down the middle of it all is the midrib. This thick central vein is absolutely crucial. It's like the factory's main support beam, giving the leaf its shape, and it's a super highway for getting water and nutrients exactly where they need to go. Super efficient design. You know, not all factories are built exactly the same, and neither are leaves. They come in all sorts of different models and have different internal pipeline systems. So let's check out a couple of the main designs you'll see out there. So on the left, you've got your simple leaf. It's just one single undivided blade, like you'd find on a mango tree. But then on the right, you have the compound leaf. This is where the blade is actually split into a bunch of smaller parts called leaflets. Think about a rosebush or a neem tree. Just two different designs for two different kinds of plants. And what about those delivery routes, the veins? Well, they have two main patterns too. Reticulate veination, on the left, is the super intricate net-like pattern, kind of like a city map with streets going everywhere. But parallel veination, on the right, is much simpler. All the veins just run in straight, parallel lines, like lanes on a highway. You see this all the time in grass and banana leaves. Okay, we've seen the blueprints, we've seen the different models, now for the main event. What does this incredible factory actually do? Well, it turns out a leaf has three super important jobs that are crucial for the plants, and honestly, for all of us. The leaf's number one job is making food. The process is called photosynthesis, and you can think of it like a secret recipe. Step 1, it takes in carbon dioxide from the air. Step 2, it pulls water up from the roots. Step 3, it uses sunlight as the energy to cook. And step 4, it mixes it all together to make glucose, that's sugar, the plant's food. And as an awesome bonus for us, it releases the oxygen we need to breathe. But wait, there's more. The leaf factory is also in charge of breathing for the plant. It's covered in these teeny tiny pores called stomata that open and close to exchange gases. And it does something called transpiration, which is basically releasing extra water to cool down. It's just like how we sweat when we get hot. All right, now for my absolute favorite part of the tour. Sometimes, to survive in really tough spots, leaves evolve and get these unbelievable superpowers. These are these special ops agents of the plant world. Check out these amazing powers. Some leaves turn into little tendrils that coil around things to help the plant climb, like you see on pea plants. Others turn into sharp spines for protection, like on a cactus. And some leaves, like the layers of an onion, are actually special storage units for food. But the coolest power of all is coming right up. Is this. Can you believe it? Some leaves are modified to become carnivorous traps. You've got the pitcher plant, which lures bugs into a little pool of digestive fluid, and of course, the famous Venus flytrap that snaps shut on anything that lands on it. Leaves that eat insects. How incredible is that? And just like that, our whirlwind factory tour is coming to an end. We covered a lot of ground, so let's do a super quick recap of the most important things we learned today. Okay, so here are your key takeaways. A leaf has three main parts, remember? The lamina, the petiole, and the midrib. Its biggest job is making food through photosynthesis, which uses carbon dioxide, water, and sunlight. Leaves can be simple or compound, and their veins can be net-like or parallel. And last but not least, some leaves have seriously awesome superpowers to climb, protect, or even eat bugs. So, I'll leave you with this thought. The next time you're outside and you see a leaf, I want you to take a closer look. What secrets will you remember it's hiding? What kind of incredible little factory will you see? Thanks for coming on this explainer with me.